Unit 3 begins with laws of exponents. Good old Algebra 1 review. This is Algebra 1 / Algebra 2, but you should have learned these things in Algebra 1. You know what the good joke is? In the Big Ideas Algebra 1 textbook, the laws of exponents are a single section. And the authors of the Big Ideas textbook think that an Algebra 1 student should be able to master those rules in 2 days. Before we had Big Ideas, before we had Florida Common Core, our textbook spent an entire chapter on the laws of exponents. So if they're a little bit rusty for you, I would understand. But these are the Algebra 1 / Algebra 2 exponent rules that we hope that you know, and I'm just reviewing with you right now. The first one shows that when you multiply two numbers with the same base, you add the exponents. Like x squared times x to the third, x to the fifth. When you multiply two numbers with the same base, add the exponents. Well, conversely, if you divide two numbers with the same base, you subtract the exponents. It's always top minus bottom, always. Of course, the base of that number can't be 0, otherwise you'd be dividing by 0, and everybody knows it's a big fat no. The third one says, when you raise a power to a power, you multiply the exponents. So raising a power to a power multiplies the exponents. When you raise a set of parentheses to an exponent, be careful. Specifically in this set of parentheses, that a and that b are being multiplied to each other. So what I've done here is I've raised a product to an exponent. I mean, we've been looking at this kind of stuff forever, right? This is not x to the third plus 2 to the third, right? The reason why is because that x and that 2 are separated by a plus or a minus sign. But if that plus sign was a multiplication dot, and it just said 2x, well then yeah, both the 2 and the x get the exponent of 3. So this third, fourth, fifth, I don't know where I am. I don't know what number that is. But that one right there says if you raise a product to a power, then both objects get the exponent. It's kind of like a distribution. It's an application. So AB to the n is A to the n times B to the n. Well, the same thing happens when it's a quotient raised to a power. So instead of a product being raised to a power, say a quotient being raised to a power, again, the object on top gets that exponent and the object on the bottom gets that exponent. So if I said like 1/2 cubed, it's 1 cubed over 2 cubed. As long as you're not dividing by 0, of course. This one here says anything raised to the 0 power equals 1, except for 0 to the 0. That's scary. Anything raised to the 0 power equals 1. And then lastly, negative exponents. I don't like when students say negative exponents flip things over. No. Negative exponents make things move across their own fraction bar. Negative exponents make things move across their own fraction bar. You know when a negative exponent does flip something over? A negative sign will flip a fraction over. If you raise the entire fraction to a negative exponent, then it flips over. But why? Well, because of this rule right here that says when you have a quotient to a power, both the top and the bottom get that power. So if I raise that a over b to the -1, that would have given me a to the -1 over b to the -1. Both objects would have moved across the fraction bar, giving me a net result of flip the fraction over. That's the only time you can say flip the fraction over. It's if the whole fraction has a negative exponent. Otherwise, a negative exponent moves an object to the other side of its fraction bar. All right, so that's just reviewing the rules. And now we're just going to do these real quick. Shouldn't need a calculator for these. Simplify using the exponent laws. All right. Well, 3 to the 5th times 3 to the 4th. I don't want the number answer. I just want to use the exponent rules. So what is 3 to the 5th times 3 to the 4th? 3 to the 9th. There you go. That's good enough. It's a huge number. We don't need to know that answer. For B, 5 to the 3rd over 5 to the 5. Well, here's what when I teach this to the Algebra 1 and to the Algebra 2 students, because in Algebra 2 they act like they've never seen these things before, is I go, look, Which one has more 5s, the top or the bottom? The bottom. That means that our answer will exist in the bottom. So what's on top? A 1. There has to be something left on top. Can't be a 0. That doesn't make any sense. But we know that the 5s will be on the bottom. And now I say, well, that looks like an S. Now I say, what's the difference between those two exponents? 2. So your answer is 1 over 5 squared. 5 to the negative second is the same answer, but we try not to have negative exponents as answers. Well, a question this simple would never exist on the test. But I think that IB would have been fine with 5 to the negative 2. Yeah. And then lastly, C, what I've got over there is a power to a power. M to the 4th power raised to the 3rd power. What do I do with those exponents? Multiply. Someone whispered it. There it is. M to the 12th. Simple. Please don't make this hard. Very, very simple. That's not IB. That's just practice. Okay? Down here, now we're going to start thinking on another level. If I tell you, hey, all of these numbers are powers of 2, and I want them all written as powers of 2. Okay, 16 is a power of 2. 2 to the what power would give me 16? 4. Yeah, there it is. So 2 to the 4th is 16. Don't overthink it. It just is. So what? So if 2 to the 4th is 16, 2 to what power gives me 1 over 16? Negative 4, yeah, because the negative would have moved that thing to the bottom of the fraction bar. That says 1 over 2 to the 4th, which is 2 to the negative 4. What's that? Okay. C, this one's fun. 2 to what power gives me a 1? There it is, 2 to the 0. Interesting thing about that is anytime you see a 1, you could write that as whatever base you want raised to the 0 power. Sometimes that's a useful trick. Now D and E are more along the lines of what IB is looking for from you. So for D, everything's supposed to be a power of 2. So that 4 is actually 2 to the 2. So when you multiply two numbers with the same base, what do you do with their exponents? Add them. So this is actually 2 to the n plus 2. Yeah, it's not wrong to say 2 plus n. It's just strange looking. It's not any more correct to say n plus 2. It just looks nicer, I guess. And then E. Trying to scroll down, that way the people in the back can see. Come on. Catch up with me, active panel. There we go. We have 2 to the m times. Now, you know what? Let's write it like this. Let's take it in multiple steps. 2 to the m over. 8 would be 2 to the 3rd. So how do I write this as a single base 2? 2 to the top minus bottom. 2 to the m minus 3. Cool, huh? We're going to begin getting into some IB level thinking very, very soon.
Why does the negative exponent make it flip over the fraction?
So why does the negative exponent make something move across the fraction bars? That's the question?
Yeah.
Okay. I showed this to Algebra 1 AB students 11 years ago. And my principal just happened, I was a long-term sub, the principal just happened to be in the room. They had never seen anything like it before. And one of them said the same thing to me. Why does this happen? And actually, the lesson was about negative exponents. So I did this for them. And I said, okay, 2 to the 3, and they go 8. And I said, great. And they said 2 to the 2, and they said 4. And I said, great. And I said 2 to the 1, they said 2. And I said 2 to the 0, and they said 1. I said, okay, now what's the pattern on the right side? I'm dividing by 2 each time. So as the exponent comes down by 1, you end up with that. Oh, snapped my microphone off my shirt. See? Neat, huh? And actually, I got Algebra 1 students to tell me, oh, so a negative sign moves it to the other side of the fraction bar. I was like, yep, that's exactly what it does. But that's why. Cool, huh? Boink. Next. Write in simplest form without brackets, by the way. Parentheses are known as brackets all around the world, just so you know. It's like in America, I think we're the only people that call them parentheses, and that brackets are the straight line things. Brackets. Yes, I don't, yeah. I'm not sure. I think they just call them, I don't know. That's a good question. I'm not sure. Write in simplest form without parentheses, without brackets, whatever. Here's what we got going on. In part A, we're just using the fact that I have a product inside this set of parentheses. So because there's a product in there, both of those objects are getting that power of 4. I'm going to do it in a couple steps. -3 to the 4th and a squared to the 4th. Well, when you raise a negative number to an even power, is your result positive or negative? It's positive. Because a positive number of negative signs is an even number of negative signs is a positive result. So I don't worry about the negative sign anymore. And 3 to the 4th is one of those things that we can actually do pretty quickly without a calculator, because it's just 3 times 3, which is 9, and 3 times 3, which is 9, and then 9 times 9 is 81. So 3 to the 4th is 81. 81. And the a squared to the 4th, whenever you raise a power to a power, what do we do with the exponents? Multiply. There it is. 81, a to the 8th. Oh boy, look at me. It's got a lot going on. You know that negative sign that's on the front of the fraction? You can either say that negative sign belongs to the top or it belongs to the bottom. I'd say just pick one. It really doesn't matter. I'm going to say that it belongs to the top, okay? And I'm going to see a quotient, and everything on top of the quotient is a product, which means that that exponent of 3 to the outside is going to be applied to all of the individual parts. So I'm going to say that the 2 is a negative. Not really anything to clean up on the bottom, it's just b to the 3rd. Well, in part A, we had an even number of negative signs. In part B, I have an odd number of negative signs. So my result will be negative. And I like my negative signs on the front of my fractions, so I already know it's going to be negative. And that 2 to the 3rd is 8. You've already told me a power to a power means multiply, so this gives me a to the 6th over b to the 3rd. And there is nothing else for you to do.
What?
What about the b?
Why don't you put it in the top?
Why would I move the b to the top?
I don't know. It looks simpler.
With a negative exponent?
Yeah.
Well, we try to stay away from negative exponents unless I've been told to write something as a base 2 or something like that. Like this last one says, or this next one says, write it without negative exponents. Typically, we don't want negative exponents hanging around. So anything with a negative exponent needs to move across its own fraction bar. That means the only one of those objects that gets to sit still is b. b already has a positive exponent. So our fraction bar, b squared. The a's are going to have to move to the bottom. And when they do, their exponent is now positive. The c's have to move to the top. And when they do, their exponent is now positive. That's not alphabetical order, but whatever. It's okay. Not a big deal. Yeah, that's all you're doing. Anything with a negative exponent, you just move it across the fraction bar and change the sign. And you know what? That's actually a pretty useful concept, because sometimes it's useful to use a negative exponent instead of a positive exponent. So you would purposely move something across its own fraction bar so you could give it a negative exponent. And you'll see what I mean in upcoming lessons. Actually, it might have. This one says write in non-fractional form. So we need our result without a fraction. Huh. Well.
Does it count if I put everything in parentheses to -1?
So what he just said to do was, he said, put everything in parentheses to do this. Now, right now, I still have a fraction in my answer. But I already told you, if you raise an entire fraction to a negative exponent, what does it do? It flips it over. Okay. So if I just flip this thing over, is it still the same number? No. Can't do that. But why does it flip it over is the question. The reason why it flips it over is because you have to apply that negative exponent, right? So what you'd be doing then is the bottom would become a 1. If you guys are okay, the bottom's a 1 still, right? But now here's what I have on top. And when you raise a power to a power, what do? You multiply the exponents. So I have a 1 minus n times a -1, and you distribute that -1. This, by the way, is way too much work for this, but it gets you the answer because Krill is being cute. But it gets us 2 to the n minus 1.
Yeah, but here's my question. Why do you need to distribute the -1? Because it says just to put it in non-fractional form.
Well, you'd want it written like that because of stuff that's coming up in upcoming lessons.
Okay, but wait. If a question just says put it in non-fractional form, wouldn't step 2 be enough?
Well, not if it's said in simplest form.
But it doesn't.
But normally it would.
Okay.
Okay. Yes. Yeah, but the reason why you're allowed to just do that is because of, like Krill said, he thought he was being funny, but that's why that works. So yeah, basically, and that's what I just said to Luca, is like sometimes it's useful to move something purposely across its fraction bar and multiply its exponent by -1, which is exactly what you would do here. I wouldn't have done all this work. What I would have done is I would have jumped straight to here. And I said, oh, I'm going to move it across its fraction bar, which means multiply its exponent by -1.
So Patrick,
Yes?
I put the 1 as 2 to the 0 and just subtracted. I don't know if that's
No, that works
different.
also. So that's another way of doing it. So let's see. Let's do it like this. We could write it as 1 over, and this 2 to the 1 minus n could be written as 2 to the 1 times 2 to the minus n. Like that? Is that what you were saying?
No, so I took the
Oh,
1
this.
up top
This
and wrote
one.
it as 2 to the 0,
All right.
and then left the 2 to the 1 minus n at the bottom. So then by subtracting,
So
the
what?
signs would flip on
So
the
you were saying
negative n and positive 1.
2 to the. I got.
N plus 1.
I got what you're saying. So that's another way of doing it, and it all means the same thing. Because when we divide two numbers with the same base, we subtract their exponents. So the top exponent would have been 0 minus, and the bottom exponent would have been 1 minus n, which again just distributes a -1, and you still get 2 to the n minus 1. So yeah, that's another reason why it's true. Yeah, that works perfectly. Yes? Well, instead of saying that I raise everything to -1, this is what Chris did. He said, okay, 1 can be thought of as 2 to the 0, right? Okay. Whenever you divide two numbers with the same base, you just subtract their exponents, correct? It's always top minus bottom. Well, that means I could have written it as a base 2, and the top exponent is 0 minus the bottom exponent of 1 minus n. So that's going to give me -1 plus n, or n minus 1. It's the same idea.
Plus 1.
No, it's -1. So think of it, pretend you just give it a value of n. Let's just use a value of n. Let's just pick an n equals, I don't know, 4. N equals 4. So you get 1 over 2 to the -3rd. Well, 2 to the -3rd is 1 over 2 to the -3rd is just 2 to the 3rd. So if you plug in 4, you still get 2 to the 3rd. So it works out. You can always use a number value to check whether or not what you did works. That doesn't prove it's true, but it checks if it's true. Alrighty, and these last two examples, yep, last two. I'm just going to give myself a little bit more space. All right. It says write in non-fractional form. Now, Dylan, just real quick, because I'm not sure if I answered your question or not. We weren't multiplying by -1. We were raising both the top and the bottom to the -1. Is that better? Okay. All right, so write in non-fractional form. Well, how do we make sure we have no fractions? Well, the way we make sure we have no fractions is by using negative exponents. So instead of saying x squared plus 3x plus 2 divided by x, would you be comfortable with me saying x squared plus 3x plus 2 times x to the -1? It's like saying divided by 2 is the same thing as saying multiply by 1/2. Same idea? So rather than saying divide by x, how about I say times x to the -1 and then distribute that x to the -1 to all three spots, giving me x to the 2 times x to the -1, and I'll clean it up in just a second, plus 3x to the 1 times x to the -1 plus 2x to the -1. You see, because when you multiply numbers with the same base, you add their exponents. So x to the 2 times x to the -1 is just x to the first, because 2 minus 1 is 1. Plus x to the first times x to the -1. Well, 1 and -1 gives you 0, so x to the 0. 3x to the 0. Well, x to the 0 is 1, so you just get 3.
No way.
Yep, and it said no fractions, so we just leave it like this. There. And this is in standard form, because the exponents are going from biggest to smallest. So that is still written in standard form. And then part B is tackled in a very similar fashion. You see, what I did in part A was I moved that x to the top and said the exponent was negative, because I just multiplied the exponent by -1. Well, look at part B. If I take that x to the -2, bring it to the top, I get to multiply its exponent by -1. So this is actually the same thing as saying 2x to the 5th plus x squared plus 3x times x squared. So I bring it to the top, I multiply its exponent by -1, and then you just distribute that x squared across all three terms, giving you 2x to the 7 plus x to the 4 plus 3x to the 3. And it is that simple.